So in this section we're going to cover simplify trigonometric expression by combining fractions. Now you did it before when we were converting into sine and cosine, combine simple fractions. Now here we have cosine of x over 1 plus sine of x. It's the same thing as cosine of theta over 1 plus sine of theta. In this example we're just using x. With the same example, plus 1 plus sine of x over cosine of x. Now, when we're combining with any fraction, the first thing that comes to your mind is common denominator, which we don't have. So, we look at 1 plus sine of x and cosine of x. So, the only way to make them the same denominator is if we multiply the left fraction by cosine of x, top and bottom, and then on the right fraction, we're going to multiply top and bottom by 1 plus sine of x over 1 plus sine of x. So doing that, we're going to have on the left fraction, cosine x times cosine x will be cosine square x over. Now I'm going to keep it separate. I'm not going to actually multiply all the way, just in case we might have to simplify. So I'm going to keep it in parentheses. Like so. Now on the top, I'm actually going to multiply. So 1 plus sine x times 1 plus sine x. Basically, we're going to FOIL. So I'm going to write the arrows here for FOIL. 1 times 1 is 1. Now when we multiply 1 times sine of x, and then sine x times 1 will become 2 sine x, and then sine x times sine x will be plus sine x squared over cosine of x times 1 plus sine of x. Now, if you can't do this in your head, I highly recommend you write it out or do the box method. Again, it's going to be a lot of work. You don't want to get lost into it, so write it out. Since they have the same denominator, we can combine the top. So it's simply going to be cosine square x plus 1 plus 2 sine x plus sine square x over cosine x times 1 plus sine x. Alright. So what I'm going to do here is check what I can do to simplify the top. So I'm going to rearrange the top because I notice I have a cosine square x and a sine square x. So let me rearrange that. So I'm going to put sine square x first, and then cosine square x, and then plus 1 plus 2 sine x over cosine x times 1 plus sine x. Alright, now the reason I rearrange cosine square x and sine square x is because sine square x plus cosine square x, that comes from the Pythagorean identity. So if we add these two, if we use the identity, sine square x plus cosine square x will become 1. So I'm going to write right here 1 plus 1 plus 2 sine x over cosine x times 1 plus sine x. So all I did was rearrange where now you see sine square x plus cosine square x using the Pythagorean identity, change it to 1, made it simpler. Now I'm going to add these two ones, so it's going to be 2 plus 2 sine x over cosine of x times 1 plus sine x. Alright, here I notice that there is a 2 in common, so what I'm going to do is I'm going to factor out that 2. So I'm going to make more room. Alright, so I'm going to write this over here. I'm going to erase this. Alright. So I'm going to factor out the 2 because they both have that in common. Now again, factoring out means divide, so I'm going to show you the work, the process. So factoring meaning divide by a common factor, which is 2. And again, it doesn't go away, it doesn't disappear. The 2, the common factor, will be on the outside of the parenthesis. 2 divided by 2 is 1. 2 sine of x divided by 2 will be simply sine of x. So I'm going to put this back in the numerator. So instead of 2 plus 2 sine of x, it will be 2 parenthesis 1 plus sine of x over cosine of x times 1 plus sine of x. So now looking at this, and again, my factors are multiplying. I notice that I have a common factor on the numerator and the denominator, 1 plus sine of x. So I'm going to divide them. So it would divide itself into 1, and I'm left with 2 over cosine of x. Now here I can actually apply one of the identities, but I'll show you how. So what I can do, 2 over cosine of x, I can rewrite it as 2 times 1 cosine of x. Because remember, when we're multiplying with fraction, a whole number and a fraction, it's just simply multiplied to the numerator. So I just factor out the 2 to make the numerator become 1. So the 2 will stay the same. Now, again, I mentioned I can apply one of the identities for 1 over cosine of x, which is the reciprocal identity. So the reciprocal identity for 1 over cosine of x is secant x. So our final answer is 2 secant x. So that's our final answer. Box that up. Now, in the previous video, including this one, we used multiple identities, the Pythagorean identity, in this case the reciprocal identity, and it was a lot of writing. So I highly recommend you write out all your steps, including the part where we had the FOIL, so that you don't get lost. And again, write it out in an organized fashion so you can observe, analyze the whole process, and double check your work. Again, so write it in an organized fashion so that you do not get lost and therefore get the wrong answer. In the second example, we have cosine of x over secant x plus 1, and then plus cosine of x over secant of x minus 1. So they're not exactly the same, so therefore they're different denominators, so they need to be the same. So what I'm going to do is I'm going to multiply the left fraction by this one right here, so top and bottom, secant of x minus 1 over secant of x minus 1. And then on the right side, the right fraction, I'm going to multiply by this. So secant of x plus 1 over secant of x plus 1 again. So, gonna actually keep these separate for now. So, I'm gonna put in parentheses secant of x minus 1 times cosine of x, and then I'm going to write plus, because since they have the same denominator, I'm going to write it as one big fraction. So cosine of x times secant of x plus 1, the whole thing over secant of x minus 1 times secant of x plus 1. Alright. Now, here on the denominator, we're going to FOIL. So I'm going to write it over here. So secant of x minus 1 times secant of x plus 1 Alright, so when I'm foiling with the secant of x times secant of x will be secant square x. Secant x times positive 1 will be plus secant x, and then minus 1 times secant x will be minus secant of x, and then negative 1 times positive 1 will be negative 1. Now if I look at the middle terms, they're both secant of x, one is positive, one is negative, so they're going to cancel out, equal to 0. So I'm left with just secant square x minus 1, which I'm going to replace over here. So we're still going to have the long denominator, but here's the thing what I'm going to do. I'm going to distribute the cosine of x to the secant x minus 1 and the secant x plus 1. So it's going to be pretty long. So on the top, it's going to be cosine x secant x minus cosine of x plus cosine x secant x plus cosine of x, the whole thing over secant square x minus 1. Alright, so yes, that's a pretty long fraction, and then I'm going to make more room, so I'm going to erase the top. Alright, now we have some more room. Alright, so what's going to happen is, I notice that we have a minus cosine of x and a positive cosine of x. So what I'm going to do, since they're both the same, and it's a numerator, we can combine like terms. So since this is a negative cosine of x and this is a positive cosine of x, when you combine them, they're going to cancel out, equal to 0. And then cosine of x secant of x is positive, plus cosine of x secant of x, that would be 2 cosine of x secant of x. So I'm going to write it as 2 cosine of x secant of x over secant square x minus 1. Now, here I want to stop because I notice, or I remember, that there is a relationship between cosine of x and secant of x. Secant of x I can rewrite it as a reciprocal of cosine of x using the reciprocal identity. So that's what I'm going to do. So 2 cosine of x will stay the same. Now I'm going to rewrite secant of x as, using the reciprocal identity, 1 over cosine of x. And again, the whole thing is still over secant square x minus 1. Now, I'm going to multiply the numerator, so it's going to be 2 cosine of x over cosine of x, and then over secant square x minus 1. Now here, we can simplify the numerator. 2 cosine of x over cosine of x will be simply just 2, and then we just have secant square x minus 1. So we made that simpler, but we still gotta simplify. Now here, secant square x minus 1, we can't really use a identity to simplify this, but we can convert it into sine and cosine, which we will do. So I'm going to write right here. So secant square x minus 1 equal, we still have the 2 on the numerator. Alright, secant square x, we're going to rewrite it as in terms of sine and cosine. So same thing as before, we're going to rewrite it using the reciprocal identity. So we're going to write 1 over cosine square x minus 1. And then to combine with this 1, we're going to change it into a fraction and then write it in the same denominator. So, as I said before, we're going to change this 1 into a fraction. So we're going to still have the 2 on the top. So it's going to be 1 over cosine square x minus, in order to get the same denominator, 1 over 1 will be the same as cosine square x over cosine square x. So since they have the same denominator, we're going to rewrite it as one fraction in the denominator. So the 2 is still the same on the numerator, but now it's going to be 1 minus cosine square x over cosine square x. Alright, we still can simplify that. I'm going to make more room. So we still have the 2 on the numerator over 1 minus cosine square x over cosine square x. Alright, so since we have a number divided by a fraction, we can rewrite it as a division. So 2 divided by 1 minus cosine square x over cosine square x, and then change it to a multiplication. So 2 times cosine square x over 1 minus cosine square x. Alright. Now, I noticed that 1 minus cosine square x, we can actually use the Pythagorean identity. So just like in the previous section, since it has a 1 minus cosine square x, that simply is going to be rewritten as sine square x. So we still have the 2 times on the top, cosine square x over, now instead of 1 minus cosine square x, it will be simply sine square x. And then we can actually rewrite cosine square x over cosine square x by using the quotient identity, which is cotangent square x. And then we're going to simplify that to simply 2 cotangent square x. And that will be our final answer. This example was pretty long, so we use the reciprocal identity numerous times, then we use the Pythagorean identity, then we use the quotient identity to simplify to 2 cosine square of x. So like I said before, since it's a long process, write your work in an organized fashion so that you do not get lost and therefore less chance of getting the wrong answer. When you're double checking, you'll be able to see your work and then see what you can do to fix it if you think it's not the right answer.